Okay, now let's look at a different type of problem involving a parallel line. So, it's a word problem. Most of them are easy if you just take it step by step. A chicken starts at point X on one side of a road. It starts walking across the road along a path that makes a 22-degree angle with the side of the road as shown. Before making it to the other side, the chicken makes a sharp turn at point Y and starts along a new path which makes a 71-degree angle with the old path, as shown. If the opposite sides of the road are parallel, what is the measure of the acute angle that the path of the chicken makes with the far side of the road at point Z? So, what this question is asking is, let's break down what it is asking for first. So, what is the measure of the acute? Acute typically just means smaller. The smaller angle that the path of the chicken makes with the far side of the road at point Z. So, that acute angle on the path on the far side of the road. So, the acute angle being this one right there. What is that angle? Now, how can we possibly find that? Well, we know the lines are parallel. Parallel is good because parallel typically tells us information like equivalent angles. However, that is only true if we have a transversal. Now, we don't really have a transversal because we do not have one line intersecting both of our parallel lines. And that's a problem. But in geometry, what's so great about it is that, ever since the ancient days of geometry, people have figured out ways to just, you can construct your own ways of solving problems. So if there's not enough in the picture to help you out, why don't we construct something to help us out, like another parallel line? Now, why would I do that? Well, mostly because I need those transversals. This whole thing's not going to work unless I have a transversal. I have lines that could potentially become transversals. If only I could get it to intersect a parallel line. Well, why not just make a parallel line? And it ends up being very nice because it is going to intersect both of our potential transversals, X, Y, and Y, Z. And what this tells me, what the transversals will always tell you is that you have some pair of equivalent angles. For example, this angle of 22 degrees and this angle must be the same because they are alternate interior. Now, this might be kind of hard to recognize, but it is just the same exact problem as here, just kind of in a weird direction. It is just an example of one angle and another inside parallel lines, but on opposite sides of the transversal. Inside parallel lines, opposite sides of the transversal XY. So now I know that this angle right here is, that angle is 22 degrees. Now I'm trying to find this angle. I'm just going to call it X. And I can apply the very same logic I just used right there. Alternate interior, they must be the same. So this has to be X. Now, where does that get me? Well, I know the entire angle itself is 71 degrees. Well, I know that if I put these two angles together, the ones I just found, they must add up to the whole. So one of those angles being 22 degrees, and the other being our mystery angle of x. So what is this going to be equal to? Well, just subtract 22 on both sides. And you will find that x is just equivalent to 49 degrees. So all that is saying is this angle right here, the one we were looking for, is 49 degrees. This is an excellent example of how you can use creative problem solving and your own ideas along with prior knowledge to come up with your own unique solutions.